So continuing with chapter 7, in the first part we did solving equations where the exponent was greater than 2, degree greater than 2. For this next part we're going to be solving, but it's going to have radicals. So we're going to have equations that have radicals that, basically it's the opposite of dealing with an exponent. Okay, so we're going to do 4 examples kind of like we did last time. Fifth root of x plus 2 equals 4. So now, instead of a power, we have that radical we're going to need to deal with. The same concepts are going to go forward here. You need to get x by itself. So I'm subtracting 2 first. So now we have the fifth root of x equals 2. And like I said, the radicals are kind of the opposite of the power. For a power, we took a radical of both sides. To get rid of a radical, we're going to take a power to both sides. So since it's the fifth radical, fifth root, I'm going to take the fifth power. The root and the radical, the root and the power cancel out. X equals 2 to the fifth power is 32. And there's no reason to worry about one answer or 2 answers. This is always going to be one solution. Okay? So get the x by itself and then take the power to both sides. So here we have 4 times the 6th root of x minus 8 equals 20. And just like before, you're going to get that x by itself. Okay? We're going to add the 8 to both sides. Divide by 4. And now we have the 6th root of x equals 7. Just like up here, it was the 5th root, so we took the 5th power. It's the 6th root, so we're going to take the 6th power. You're going to get some large numbers here. 7 to the 6th power, I'm not expecting to be able to do it in your head. Take your time plugging in your calculator and transferring from the calculator to the paper. You should get x equals 117,649. Okay? So take your time writing out these answers. Some of them will be pretty big. Now here for the next one. The 4th root, x minus 3 plus 2 equals 13. Now, that x minus 3, it's all in the radical. That's kind of it is grouping. It's just like parentheses. We can't do anything inside there until we get rid of everything else. So the first thing is subtracting the 2. And now, again, you can't do anything until you get rid of everything else. I'm going to take the 4th power to both sides. Okay? So that cancels out the radical, so we're just having x minus 3 equals, again, 11 to the 4th, a fairly large number, 14,641. And the last step there is to add that 3. So we have 14,644. Okay? So it's important. Get rid of everything first. Make sure you get rid of everything away from the radical. If there's other things in the radical, take care of the radical first. Okay? So here we can see we had to get rid of the 2 first. That's not inside the radical. Then take care of the radical, and then we could do what was inside, getting that x by itself. Okay? And this last example, I just want to show you just to take your time and look at the problem carefully. So here we have 5 times the square root of 2x minus 1 equals 10. A lot of times people will just real quick look at this problem and say, it's the 5th root of 2x minus 1. This is 5 times. Okay, so you really have to take your time and look at the problem. In this problem, you want to divide by 5 first. Don't just go ahead and take the 5th power. Divide by 5. Square root of 2x minus 1 equals 2. And from here, you're just going through the work to take the 2nd power to both sides. It's a square root. Square root, you won't see the index. So if you don't see it, you know it's a square root. You're going to square both sides. 2x minus 1 equals 4. And now it's just a linear equation. 2x minus 1 equals 4. add your 1, divide by 2. X equals 5 over 2, or if you want to write it as 2.5, that would be acceptable as well. Okay? So that's solving radicals. Okay? The last video on here is I'll show you just some special situations that you might deal with in this chapter.